Morning, everyone. My name is Michael George. I'm from EC department. I'm submitting this video as part of my presentation. In this video, we'll look into simplex algorithm and optimization techniques. We'll see what is simplex algorithm and optimization techniques. See, the simplex algorithm is widely used to solve linear programming problems when the given objective function and constants are in linear equations. Then we use the simplex algorithm to solve those linear programming problems. It was developed by George Danzig in 1947. So before we look into what is simplex algorithm, we'll see what is linear programming problem. When the given objective function is linear equation and when the given constants are linear equation, then we can say the given problem is linear programming problem, and we'll use the simplex algorithm to solve those linear programming problems. So the main purpose of optimization is to find the best possible value of the objective function. We'll maximize the objective function or minimize the objective function in simplex algorithm. See, the important part in simplex algorithm is that when the given constraints, the constraints will be given and inequalities, uh, depending on the inequality type, will change the inequalities into equations. So here the conditions are given to change the inequalities into equations. When the inequality type is given less than or equals to, we'll introduce the slack variables. When the inequality type is more than or equals to, we'll subtract surplus variables and add artificial variables. When the inequality type is the when equality type is given, then we'll add artificial variables. So we'll change the inequalities, the constraints of a problem into equation. Uh, the first step in simplex algorithm is to convert the constraints of the linear programming problem into system of linear equations. We'll change the inequalities into equations by using these conditions, and we'll find a basic feasible solution by setting some of the variables to zero, and we'll solve for the remaining variables, and we'll repeat the process. We'll repeat the process as iteration 1, iteration 2, iteration 3. We will do the process, we'll repeat the process until the optimal solution is found. When the optimal solution is found, we'll end the process and the optimal solution is found. Uh, for example, this is an example of an objective function. Here, the maximize 3x plus 2y. This is objective function, and the inequalities are given here. 2x plus y less than or equals to 18. 2x plus 3y less than or equals to 42. 3x plus y less than or equals to 24. These are the inequalities constraints, and x is more than or equals to 0, y is more than or equals to 0. These are the non-negative constraints or restrictions. So we'll see what is simplex algorithm. We'll see how to apply simplex algorithm to a given problem. See, the first step in simplex algorithm is, if the given problem is the given problem is to maximize the function, then it's okay. If the given problem is minimization problem, then we'll multiply the objective function by minus 1. And if the problem contains any constant with negative right hand side, then we'll multiply each constant by minus 1, so that we'll get only positive values. And as we discussed earlier, based on the inequality type, we'll introduce slack variables, uh, or we'll introduce artificial variables and surplus variables depending on the inequality type to the constraint. If the we'll add a slack variable to a less than constraint, or we'll subtract a surplus variable and add an artificial variable to each more than or equals to constraint. And we'll add artificial variables if the given constraint equation is in equal type. So we'll this is the first uh, uh, important step in simplex algorithm. And now the important point is we'll determine the entering variable, which is called the pivot column or key column. And uh, we'll determine this by using cj minus zz. We'll determine the most positive value, and depending on the ratio, will determine the pivot row or key row. Um, these are the steps to be followed when solving a problem using simplex algorithm. See, firstly, we will identify the variable with most positive value in the Cj minus z row, and this is a column that this is the entering column, and this is called pivot column or key column. And we will determine leaving variable for each positive number in the entering column. We'll compute the ratio by dividing with the entering column elements, and we'll divide the pivot row, which is leaving row, by the pivot elements. And we will get the pivot element. The pivot element is a intersection of the pivot row and pivot column. And again, the replace each non-pivot row with the new row. And this is a formula which we use to compute the new rows. That is current row minus entering column elements into the new row. And these are the steps to be followed. Now we look into an example. See, we'll repeat the process until the optimal solution is found. Um, Now we look into an example to clearly know what is simplex algorithm. See here, the given problem is linear programming problem, because the given equations are linear equations, and we have here inequality types, and this is objective function, and these are the constraints. Um, we'll see this is the less than or equal to type. So we'll introduce slack variables and we'll change these inequalities into equations. Here we have introduced x3, x4, x5 as slack variables. See here in this problem, we have replaced y with x2, so that we'll have all variables uh, same. So we can keep the variables as x1, x2. So for our convenience, we have replaced y with x2, and here we have introduced x3, x4, x5 as slack variables, and we have changed the inequalities into equations. We have introduced, and this and the same these variables we have used in objective function. See, these are called the basic variables. Here, the coefficient of this basic variables is 0 in objective function, but in equations, the coefficient of this basic variable is 1. But in objective function, the coefficient of basic variables will be taken 0. Now we'll see the first table or the first iteration of simplex algorithm. Here, these are the 18, 40 to 24, or these are the right hand side values. And this P1, P2, P3, P4, P5, they are like P x1, x2, x3, x4, x5. Um, we have taken the coefficients of these variables P1, 2, and P2, 1, P3, 1, P4, 0, 0. See, here the x3 coefficient is 1 and x4 coefficient is, I mean, P4 or x4 same. X4 coefficient is 1 and x5 or P5 coefficient is 1. In this table, we have taken like Zj minus Cj. If Cj minus Zj is taken, then we will take the most positive value. Or if Zj minus Cj is taken, then we'll take the most negative value. In some books, it is given as Cj minus Zj, and in some textbooks, it is given as Zj minus Cj. So in this example, we have taken Zj minus Cj. So in this problem, um, this is a we got minus 3 is the most negative value. So this is the pivot column or key column, and we will compute the ratio by dividing this pivot elements by dividing by dividing this RHS by pivot elements. Here 80 by 2 9, 42 by 2 21, and 24 by 3 8. So we will get 8 here. In this, 8 is a minimum. So this is a pivot row. So this is a pivot column and this is a pivot row. And the intersection of this pivot row and pivot column is pivot element. So here 3 is pivot element. Um, and we this is a Zj and this is a Cj. 0 into 0 into 2 and 0 into 2 and 0 into 3 and 3 uh, 0 into 2 plus 0 into 2 plus 0 into 3 0. So 3 minus, see, this is Cj, this is Zj. So minus 3, 0 minus 3, minus 3. And the same goes here like this: 0 into 1, 0 into 3, 0 into minus 0 into 1, 0. And this is a Zj. Zj minus Cj, 0 minus 2 and minus 2. And the same goes like this. And after this, we'll so here P5, which is x5, is a entering, I mean, this is a leaving row. This is pivot row, this row will leave. And this is the entering column, pivot column. And the second iteration, in the second iteration, we have seen that P1, here the P5 is replaced with P1. So how we get P5 is we'll divide the we'll divide this pivot row by pivot element. See here, 0 minus 3, 24 minus 3, 3 minus 3, 1 minus 3. So we get 0, 24 minus 3, 8, 3 minus 3, 1, and 1 minus 3, 1 minus 1 by 1 by 3, 1 by 3, 1 by 3. And the same goes like this. And this is the new row. And how to compute these another two rows? Here comes the important point. We will use a formula. We have seen this is a formula. To get the new row, what we do is current row minus this is the entering column element into new row. This is a new row. We denote this row as a new row. So what we do is here is mm, Here we have found the other two rows by using that formula, and by using that formula we get here uh, two. These are the rows we get by using the formula, and the third iteration, and here we can see that -1 is the most negative value, and this is a pivot column. And when we compute the given ratios, then we can see that this row is getting the minimum ratio. So this is a pivot row, and 1 by 3 is a pivot element. So this row is a leaving row. Now we will divide this row by 1 by 3 pivot element. Here 1 by 3 is a pivot element because it is the intersection of pivot column and pivot row. And after solving, we get the after solving we get a new uh, table. Here 2 0 1 by 3 1 0, these are the pivot row elements. This row is leaving, so we divide this row by 1 by 3. So 2 1 by 1 by 3 is we get 6, and 1 by 3 by 1 by 3 we get 1, and 1 by 1 by 3 we get 3, and this is how we get this row. And the other two rows we get by using the formula as we have discussed earlier. And this is a fourth iteration table. And in this, after solving using the above procedure, we get that 33 as a most positive value, and the other we have only positive number or 0. So this is a point where we should stop, because we have found the optimal solution, and here 33 is the optimal solution we have found. And in this example we have taken zj minus cj, so that is the reason why we are taking most negative value as a entering column or pivot column. And in the end, when we get zeros are only positive values, then the optimal solution is found. For example, in the given problem, if we take cj minus zj, then we would have taken the most uh, positive number as a pivot element, as a entering column. And in the end, when we found the negative numbers or 0, then the optimal solution is found. Now we look into another example to get a clear understanding of the simplex algorithm. And we'll look into the other example. And the simplex algorithm has many applications in engineering and in many fields. We use simplex algorithm in wireless communications. We use in process optimization. We use it in industries. We use simplex algorithm in chemical and industrial processes, like uh, it can be used to determine the optimal combinations of reactants, like to maximize the profit, maximize the given material, and to reduce energy consumption. We use it in resource allocation, like resources such as manpower, equipment, and materials, uh, to maximize the work using less manpower. uh, what are the ways we can uh, do using simplex algorithm, we can find the solution. And it is used in control algorithms, and it is used uh, in control systems. It is used to determine the optimal control strategy for a chemical process, and it is used in structural optimization. uh, Now we'll look into the other example where we take Cj minus Zj. So this is the given LPP problem, linear programming problem, and here uh, here the we have changed the inequalities into equations by adding slack variables. Here we have added S1, S2, S3 slack variables, and we have changed it into equations. And we have these are the basic variables, and we have added this variables in the optimization in the objective function. And we look into the first table. See here, these are 36, 50, 60. These are the right hand side values, and we have taken the coefficients of these equations here, and s1, s2, s3 are the basic variables, and the coefficients of these basic variables will be taken as 0. This set of basic variables is called basis. So in the first iteration table, we'll take the coefficients as 0 for the basic variables s1, s2, and s3. And here, um, this is we will determine the zj by will uh, and cj. Here the basic variables are 0. So 0 into 3, 0 into 5, 0 into 2, uh, we get 0. So 20 minus 0, we see, so this is a cj. 20, 30, 0, 0, 0. These are the cj values. And zj values are, we have computed. These are the zj values. 0 into 3, 0 into 5, 0 into 2, 0, and 0 into 3, 0 into 2, 0 into 6. And 0 into everything is 0. So the answer is 0. So these are the zj values. Now what we have done is we have computed here as cj minus zj. In the previous example, we have seen zj minus cj. So we have taken the most negative value, but in this example, we are taking cj minus zj. So we will take the most positive value. And after computing this, 20 minus 0, 20, 30 minus 0, 30, 0 minus 0, 0, 0 minus 0, 0, and 0 minus 0, 0. So in this Cj minus Zj, we can see that that is the most maximum value. So we will take this as pivot column or key column. Now we'll see what is pivot row. So how we take pivot row is we will divide the right hand side values, which are 36, 50, 60, by pivot elements. See pivot, I mean this pivot column elements. Here 3, 2, 6 are the uh, pivot column elements. So when we divide 36 by 3, we get 12, 50 by 2, 25, 60 by 6, 10. So this is a ratio. So 10 is a minimum ratio. So this is the pivot row. So this is a living row, and this is a entering column. So here 6 is a pivot element because this is the intersection of pivot element and pivot row. So 6 is a pivot element. And uh, so we now in the next table, what we do is we'll divide this pivot row by pivot element, which is 6. So we'll divide 60 by 6, 2 by 6, 6 by 6, and 0 by 6, 0 by 6, and 1 by 6. So here we get 10, 1 by 3, 1, 0, 0, 1 by 6. And the other two columns, I mean other two rows, see this is a row which we got by dividing the pivot row by pivot element, and the other two rows will be calculated using the formula which we have discussed here. So this is the formula which we use to compute the other two rows. Here uh, this is a new row, and the S1, S2 row is found by will will multiply the new row by the element 2. So because we are trying to find the second row, so we'll divide it by the second uh, second row element, second row column element, which is 2, and will subtract that new row from 55 to 010. So here we will multiply by 2, 20, 2 by 3, 2. After multiplication, we'll subtract. When we subtract 50 minus 20, so see here, first we are multiplying by 2, which is 20, 2 by 3, 2. And after that, we are subtracting from second row, which is 50. So 50 minus 10, 50 minus 20, because we have multiplied by 2, and 30. And 5 minus 2 by 3, that is 13 by 3. And 0 minus 2, and here 2. 2 minus 2, 0. And 0 minus 0, 0. And in this way we have found the second row. And in the same way we will multiply the new row by 3, which is 30. uh, and here we'll get 1, 1 by 3 into 3, 1, 1 into 3. And after this we'll subtract the new row from this row, 36, from S1. 36 minus 36 minus 36, here 36 minus 30, which is 6. And 3 minus, here 3 minus, which is 3. So here we get we have multiplied this 1 by 3 by 3, and which is 1. So here the value is 1. So 3 minus 1 will get 2, and 3 minus 3, 0. And this is how we computed the other two rows. And this is the second iteration table. And in this, we have found that these are the two rows. Now we'll compute this ZZ. 0 into 6, 0. 0 into 30, 0. 30, 30 into 10, 300. So we'll add all these numbers. We'll get 300. And the same goes like this: 0 into 2, 0 into 13 by 3, 30 into 1 by 3. Uh, and after this, subtracting from 20, then we'll get 10. So these are the values of Zj. And when we subtract Cj minus Zj, 20 minus 10, 10, 30 minus 30, 0, and 0 minus 0, 0, 0 minus 0, and 0 minus 5, minus 5. And here we found that 10 is the most positive value, and this is a pivot column, which is the entering column. And we'll compute the right hand side values by divide we'll compute the ratio by dividing the RHS by this pivot column elements. Here 2, 13 by 3, 1 by 3 are the pivot column elements. So we'll divide it by 6. These are the right hand side values: 6 by 2, 3. And 13 by 13 by 3 will get 90 by 3. 10 by 1 by 3 will get 30. So in this, 3 is the most least value. So this is a pivot row, which is a living row. And 2, this is a pivot element we have found, because this is an intersection of pivot element and pivot column. So 2 is the pivot element. And now will this is the living row. Now we get the new row by dividing this pivot row by 2, 6 by 2, 2 by 2, 0 by 2, 1 by 2. And this is the values we'll get. 3, 1, 0, 1 by 2, 0, minus 1 by 4. And the coefficient of this new variable is 20. And the other two rows are found by using the formula we discussed earlier. Uh, and after using this formula, uh, we can say that this is a new row we got by dividing by pivot element, and S2 Y, these are the rows we got by the formula. And after this, what we have done is 20 into 3 plus 0 into 17 plus 30 into 90, we will get 330. And um, 20, and these are the values we get, ZZ values. 20 into 1, 20, and 0 into 0, 30 into 0, 0. So 20 minus 20 is 0, 30 minus 30 is 0, 0 minus 5, 5, 0 minus 1, 5 by 2 minus 4. So in this, we have found either zeros or negative values, but no positive values. So this is a point where we should terminate, and we have found the optimal solution. And the optimal solution is 330. This is a point we should stop the process because we have found the optimal solution 330, because we have only negative values or zeros but no positive values. So 330 is the optimal solution for this given problem. Thank you.